Hello, and welcome to this edition of the Satellite Image Deep Learning video podcast series. Today I'm talking with Caleb Robinson. Caleb is a research scientist in the Microsoft AI for Good research lab. His work focuses on tackling large-scale problems at the intersection of remote sensing and machine learning and computer vision. Some of the projects he works on include estimating land cover, poultry barns, solar panels, and cows from high-resolution satellite imagery. Caleb is interested in research topics that facilitate using remotely sensed imagery more effectively. Without further ado, I give you Caleb. Hi Caleb, how are you doing?
Hi, good. How are you?
Yeah, very well, thanks. Great to have you on the show today. I'm really looking forward to hearing about TorchGeo.
Yeah, we've put a bit of time into it, and I hope that it can kind of help other people use remotely sensed data.
Cool. So, at a high level, what's the main problem that you're trying to solve with TorchGeo?
Yeah, so motivation here is that kind of at the intersection of machine learning and other domains like vision, like NLP, there is a lot of software infrastructure that helps research scientists and practitioners use the tools that we have in machine learning and deep learning with data from the other domains. And we really saw that didn't exist for remotely sensed imagery. And kind of wanted to create that tool to fill the gap. And then just for our own purposes, we do a lot of kind of machine learning with satellite imagery. So wanted a tool to make that easier.
And this is your own purposes being yourself a Microsoft.
Yes, yeah. Sorry to introduce myself. I'm a research scientist here at Microsoft, and our group focuses a lot on projects that have satellite imagery.
Cool. Well, it'd be really great to have a quick look at TorchGeo.
Yeah. Do you want me to share my screen?
Yeah, go for it.
This is the GitHub repo. It's a open source project here on GitHub. You can pip install TorchGeo. You can conda install TorchGeo. We've really spent a lot of time on making sure that it's easy to work with all of kind of the sub-dependencies that have traditionally been a little bit difficult to get working all together. So that's actually, I think, a big contribution of the project as well. And yeah, again, our goals for the library are kind of stated right here at the top. We want to make it simple for machine learning experts to work with geospatial data, and for remote sensing experts to explore machine learning solutions. And really what TorchGeo is, it takes after kind of the TorchVision library. If you're familiar with that, you have datasets. We added data modules, samplers, and trainers that all work with geospatial data. Right. So to give just a very, very simple example of what you can do with it, Landsat 7 and Landsat 8 are both different kind of missions that grab satellite imagery over the surface of the Earth. And if you want to use that data with a PyTorch type machine learning setup, you're going to need to write a lot of custom code. What TorchGeo does is let you instantiate a torchgeo.datasets.landsat7 or a .landsat8 object that can sample kind of without having to know about all the different complexities that come with geospatial data, like coordinate reference systems, like how to deal with multispectral imagery, that just samples kind of directly from the data. So right here as a code example, maybe I can zoom in to make it a little easier to see. You create the Landsat 7 dataset, you create a Landsat 8 dataset, and then you can create a union or intersection datasets out of kind of individual datasets.
Right, that's a really nice short syntax there.
Yeah, here now you have a dataset that you can draw samples from both of these at the same time. If you have, for example, a layer of labels, this is the Cropland data layer dataset that contains crop type layers over the United States, and you have Landsat imagery, I think, as we're showing in this picture here. And you want to sample from both of them at the same time, maybe to train a semantic segmentation model. You can use here the intersection data set. So this one will actually go and download the data to your local machine. Dataset now is a intersection between the two of these. And then when you sample from it, you'll be only grabbing layers or imagery and masks from both of these layers where they're both defined.
Right. And is it doing a spatial sampling or temporal as well, or can you select like which dimensions you can sample across?
We technically do have temporal information built in. We extract kind of the date out of both Landsat scenes and Cropland data layer scenes. I don't believe any of our samplers allow you to specify a time dimension. And the way that samplers work is you can define a random geosampler. You can define like a gridded geosampler, for example, and it will kind of pay attention to the valid bounds of the dataset object to grab patches.
That's interesting. So the random sampler, would that make sure that you didn't like mix up your data set, like the same spatial locations in train and test?
Yeah, you can also pass a region of interest to this one. So this data set is going to be defined as kind of the intersection between this Landsat scene and this Cropland data layer. And by default, it's going to take that whole intersection area. If you wanted to have like a train test split, you could then further define like a GeoJSON polygon that says, this is my training area, pass it as the ROI to this sampler, and then it would only be grabbing from that area.
Wow, that's really cool. And I can see how that'd save a lot of time with data set preparation for people, particularly that don't have, the background in geospatial data.
Yeah, it's so easy to make mistakes. Your coordinate systems need to be aligned. If your different data layers are kind of different resolutions, this is automatically going to resample and reproject them to the same resolution. So you don't have to worry about having, for example, a pixel here that doesn't line up perfectly with pixels in your other layers. But yeah, just from personal experience, it was so easy to make mistakes when working on these types of problems. So TorchGeo, I think, is using it for my own projects. I'm much less bug prone now.
Cool. Yeah, it's always good to get those bugs out of the way early. So you've got the data sets taken care of. Is it straightforward for somebody to import their own like custom data set?
Yeah, so I guess a little bit of how this is organized. We call these geodatasets, any data set that has kind of geographic metadata. And all of these, for the most part, extend a raster dataset. If you have just kind of arbitrary GeoTIFF files that you want to use with this same sort of syntax and features, you can just pass it, for example, a directory, and it'll go through and find everything that raster.io can load and use that. Another whole section of the library is we've also implemented a large number of just benchmark datasets that kind of exist out there in the literature that you might want to use if you're running experiments on something. If we go to the documentation up here, there should be actually a list. So yeah, this is our docs page. Here's the datasets page, and we've again got it separated out into geospatial datasets and non-geospatial datasets. If you have a better naming convention, we're happy to change that. We're not quite set on that yet. But yeah, here is the list of the different kind of specific datasets with geographic metadata that we've implemented. These are kind of the usual candidates: Landsat, Sentinel, NAIP imagery is high resolution aerial imagery over the US. But then the non-geospatial datasets are ones that you might want to include in like a academic paper. And we're also kind of really happy with these as one of the other motivations, and some of the work that we did in the research paper that we published about TorchGeo was just creating simple benchmarks to see how just UNets, vanilla UNets that are trained with proper hyperparameter tuning are performing on some of like semantic segmentation data sets here.
Yeah. And do those data sets also encode like a train, validation, and test split to them?
Some of them do. We try quite hard to, if the dataset has defined splits, to make it easy to use those splits. And if we don't, we implement random splitting.
Okay, cool. So this should make all that sort of benchmarking and all the papers that we see a lot more straightforward for the authors. And I guess the hope is that they will therefore do it.
Yeah, as a reader of papers and a reviewer, it's always quite challenging to understand what exactly a proposed method is bringing to the table if it's not benchmarked against kind of existing data sets, or doesn't include a bunch of comparisons within the own paper. So we're really trying to kind of start the leaderboard type approach that's used a lot in computer vision on kind of remotely sensed data sets.
Cool. I see you've also got TorchGeo losses and models there.
Yeah. So there are other components of the library. These aren't as well developed, but if there are any sort of loss functions or models that are specific to geospatial data and not just something that we can port over from vision packages quite easily, we go ahead and implement these. So for example, this RCF extractor, this was kind of proposed in a paper, multitask observation using satellite imagery in kitchen sinks. And it's a unsupervised way to do feature extraction at a patch level from satellite imagery that's quite nice. And this is just a one-liner drop-in if you want to instantiate that and use it in your project.
Cool. I've seen so many papers where they like implement from scratch their own like losses, and sometimes you see differences in how that's done. So it'd be really reassuring to see like a source of truth for those. Yeah,
and again, that's just a vector that bugs can creep in. Even with kind of vision papers, people re-implement things, and there are really, really good packages out there so that you don't have to do that, and you can kind of focus on the idea rather than the coding behind it.
Cool.
So just a couple more interesting bits of the library here. So if you're familiar with PyTorch, you have the idea of datasets. Datasets just kind of interact with the data directly. Data loaders are what you use in your training, testing, inference loops. And then you need one of those for each of your train, val, test splits. And PyTorch Lightning, add-on layer on top of PyTorch, introduces this concept of data modules that are a self-contained class that define this along with sort of the augmentations, pre-processing that you'll need to actually train something. So we also have data modules implemented for some of the, a smaller subset of the non-geospatial data sets that we have. That if you're looking to train models on, this is the only thing that you need. These are absolute drop-in components for doing experiments.
It'd be really great to see like the real minimal, notebook from data module to training.
Yeah, I can hop over to my kind of Jupyter Notebook environment. So this notebook is an example that I gave at the IEEE Computer Vision School a couple months ago. And it runs through an example of how to do change detection with a specific data set that we have in TorchGeo, just kind of all self-contained within kind of one area. So let me restart this and run it from the top here. So the first thing that you're doing, obviously importing, checking to make sure that you have CUDA online, that you're going to be doing training on GPUs, just defining some parameters. And then here's where the TorchGeo part of things come in. So this Levier CD plus data set is one out there in the literature, deals with change detection. And you can instantiate the train and test datasets just like this. If they're not downloaded, it's going to go and download them for you. Make sure that it's not corrupted. It'll do all that. And then this is a kind of example of how you can customize. So the only part of the library that I didn't talk about is the trainers. We've implemented a couple of different PyTorch Lightning modules that allow you to take TorchGeo datasets and train the models on different common tasks. So image patch classification, semantic segmentation, regression problems. They're kind of pre-built tasks for this. This is an example of how to extend the semantic segmentation task that we have to deal with change detection in this particular dataset's case, as it's formatted a bit differently. So all you really need to do is rewrite the training loop and validation loop, and then you're good to go. You can train models. So if I start that, this is the data module for this particular data set. You can see we're defining augmentations here. It's a really important part about getting good performance with data sets. Defining random validation splits, and then the different data loaders that you'll need. And then setting up an actual training example is now as easy as instantiating the data module, the custom semantic segmentation task that we defined above. We're using a UNet with a ResNet 18 encoder using ImageNet weights. This model is going to take in as input a before and after image. Each are RGB, so we have 6 input channels. And then the 2 output classes are something changed or something didn't change. And then kind of really easy to define other things that we want to do, like model checkpointing, early stopping, and logging the tensor board. We just run that. And then training is defining a PyTorch Lightning trainer. You can also pass some parameters like the number of epochs you want it to run for, and then call .fit, and it should be off to the races. And then you can pull up TensorBoard in another window and you can see its progress.
Yeah, I really love the abstraction layer there with the class around the trainer.
Yeah, if you haven't used PyTorch Lightning before, I highly recommend it. You just kind of organize your training code a little bit differently, and you get a bunch of really nice things for free, like .fit. Yeah, it does a couple of checks before training starts to make sure nothing's broken, and then epoch 0 again is off to the races. After that finishes training, you can kind of test it in a similar way. Nice. So yeah, TorchGeo has a bunch of these already implemented, and for the results that we show in our paper, we're using all of this code as well. So our paper results are reproducible.
Very nice. And TorchGeo is under active development then?
Yes, very active. We're hoping to release version 0.4 here in the next couple of weeks before the end of the year. There are a lot of different features that we're still looking to implement. One big thing is just a lot more tutorials on how to do different types of tasks. Jumping back over to the docs, we do have a couple of tutorial notebooks show getting started, basically what we had in the README that I was looking through, how to do, this is the direct answer to the question that you asked earlier, what happens if you have raster datasets that aren't fitting in with any of the existing implemented datasets? This is an example of what you can do and how you can extend the raster dataset class to deal with different imagery. Examples of how to do the transforms, like if you wanted to include NDVI as an input layer, you can compute that on the fly instead of having to pre-compute that. A different example of how you can use the trainer here. This one is estimating wind speed from satellite imagery of hurricanes. And then finally, if you want to benchmark kind of training speed, we have an example for that too.
Cool.
But our main focus next is going to be kind of really fleshing this out and showing how TorchGeo can work in a bunch of different environments, like the planetary computer. What happens if you have custom GeoJSON labels that go with your imagery? How do you rasterize those, then use them in a trainer? Bunch of different directions.
Wow,
plenty to do.
Yeah, and you get to do this as your day job. That's fantastic.
Yep. At the Microsoft AI for Good lab, we're a total philanthropic arm of Microsoft, and this is one of my main projects.
Yeah.
So full-time job is developing TorchGeo and working on other related projects.
Fantastic. That's a really good introduction to TorchGeo, and I think it's going to get a lot more attention in the future. Really looking forward to seeing the new release you just mentioned and all the extra documentation that's going to come our way.
Yeah, thanks. If you have any suggestions of what we can do next, how we can make it better, we always love to hear from people. And our issues queue is plentiful, but would love to see comments or suggestions.
Love that. Open invite for more issues, please.
Yeah.
Put them here. Cool. I'll add the GitHub location in the show notes as well. Fantastic. And if people want to follow along, your progress, what's the best place for them to follow you?
We have a website, aka.ms GeoML, that highlights a lot of the kind of geospatial-specific work that we're doing here at the AI for Good research lab. Just highlights kind of the different projects that we're involved in, kind of publications that we have, who's part of the group, any artifacts that we're releasing, like TorchGeo or other repos for accompanying projects. You can all find them here.
Fantastic. That looks like a gold mine. I'll be checking that out very soon.
Thanks.
Fantastic. Well, thank you so much for coming on the show today and telling us about TorchGeo. And I hope to hear about the future progress at a later date as well.
Yeah, thanks for having me, Robin. That's great.